Let S be a non-empty subset of R if S is finite union of disjoint bounded intervals, then which one of the following is true? First statement, A statement is if S is not compact, then supremum of S is in S and infimum of S is not belongs to S. Supremum of S is not belongs to S and infimum of S is not belongs to S. Means supremum and infimum both are not belongs to S. Even if supremum and infimum belongs to S, then S need not be compact. So we have to check this point also. If supremum and infimum both are not belongs to S, then S is compact. If S is compact, then it is not necessary that supremum of S and infimum of S are not belongs to S. So means there is two types of information which is given in this statement. If set is compact, then we have to check supremum is belonging to S or not, as well as for infimum. If set is not compact, then we have to check supremum and infimum is belonging to S or not. Means we have to go from compact to if it is given compactness, then we have to check supremum and infimum in S, and if supremum and infimum is in S, then we have to check compactness. Means compactness to supremum and infimum and vice versa. So we have to check this type. So first we have to an idea what is compact. So compact compactness of the set, it means closed and bounded. Means all limit points should be in the set, means derived set. You can say in other terms derived set, and bounded, it means supremum and infimum should exist for the set. This is compactness. And we know that supremum and infimum of a set may and may not be exist in the set. So come to the statement A, and we have need to check. So if S is not compact, S is not compact, then we have to check its supremum and infimum is in S or not. And what is S? S is union of disjoint, union of disjoint bounded interval, disjoint bounded interval. As a interval, so we have sufficient information or some predefined or pre-information we can easily use here. As a consider, because of finite union, this is finite union of disjoint bounded interval. So consider S1 is interval, this is open, semi open, 0 1, and S2 is -1 to 0, this is semi closed. So union S is the union of S1 and S2. So as option A says, if S is not compact, so we have to check S is compact or not. As 0 is the limit point, 0 is the limit point, but 0 not belongs to S. You can see here S is union of S1 and S2. So in union 0 is not there, but 0 is the limit point. How? You can consider a sequence 1 by n. This sequence is in S or precisely in S1. So, but 0 is not there. 0 is the limit point of this sequence. It means for infinitely many values of S, infinitely many values S exist, but limit point is not. So S is not closed. S is not closed, but supremum of S. What is the supremum of S? Supremum you can find for this set. Supremum will be 1. Supremum of this set S is 1, and infimum of S is -1. So supremum and infimum is exist, and S is not compact. So option A is false. Even supremum and infimum exist in set S, but S need not be compact. Supremum and infimum exist, and S need not be compact. It is true because 0 is the limit point, but 0 is not in S. So this statement is true. If supremum of S is not in S and infimum of S is not S, then S is compact. So you can consider as what is given: supremum of S is not in S and infimum of S is also not in S, then S is compact. S is compact. So again consider S1 is open interval 0 1, and S2 is open interval this. 0 is the limit point. 0 is the limit point, but not in S. Also supremum of S is 1, but not belongs to S, and infimum of S is -1. This is again not in S. So both hypothesis is true, but conclusion is not true. So supremum and infimum exist and not in S, then S is compact. So this statement is not true because 0 is limit point of S. Even S is compact, it is not necessary that supremum of S is not in S and infimum of S is not in S. So we have shown this point also. When S is compact, so you can consider S is compact, so you can take S1 as this is semi closed, and S2 as -1 to 0. So 0 is the limit point, and this is -1 to 0, but supremum and infimum both are not in S. So this is it is not necessary. So you can take right closed here and left close. So supremum is also in S, and infimum is also in S. So you can say this statement is coming false. So only statement B is correct.